Hello, my little mathematicians. Today we are going to be continuing 13.4, finding the area of composite shapes, or sometimes just referred to as polygons. Now they're called composite shapes because they're made up of multiple shapes put together. It says continued because this is very helpful if you first of all already did the foldable that went along with this. And if you'll notice, this is the same exact problem of example 1 in our 13.4 foldable, finding the area of polygons. Okay. As a review, let's first of all do this using addition, okay, which means I'm going to divide my figure right here on this dotted line. And I'm going to first find the area of that top rectangle. Notice how I said rectangle and not square, even though it kind of looks like a square, because it's not exactly perfectly even. It's 6 by 5. Okay. So that top blue rectangle and that bottom orange rectangle, if we add those two together, okay, the top blue, which is 5 by 6, and we also add that bottom orange rectangle, okay, which is 13 by 9, I'll get my total area of this composite shape, which looks kind of like an L. I want you to always get in the habit of, when you break the shapes apart, redraw them off to the side of the individual shapes that make up your overall shape. Label it, because eventually they're going to get more and more confusing where there's missing numbers and you have to figure out the missing numbers. And I also want you to get in the habit of writing the formula beneath them, because yes, right now we're just dealing with two rectangles, but eventually we could have a rectangle and a trapezoid, and a triangle, or a trapezoid and triangle, etc. So always get in the habit of writing your formula beneath each shape, so then you never do something extra or you don't forget to do something. For this blue one, since we're dealing with a rectangle, my formula is base times height, which means I'm going to do 5 times 6, which is 30. That doesn't seem like a big deal to write that out, but you would be amazed at how many times I get quizzes back and they divided by 2. And I'm like, why did you divide by 2? Well, because other times I divided by 2. Yeah, when you're dealing with a triangle or a rhombus or a trapezoid, does that look like any of those figures? No. Okay, well, so then don't do it. And the easiest way to not fall for that trap is if you actually had the formula written ahead of time, then you won't accidentally do something silly. All right. So sorry for going off on that tangent. It doesn't seem like a big deal, but so many times people make that mistake and they just randomly do something because they're like, oh, I didn't have anything written down. So I'd done it before where I divided by 2. Write your formula down. Hopefully that sunk in. Okay. We've established that the area of that blue rectangle is 30. Now let's find the area of that orange rectangle. And yes, I wrote the formula again, okay? And it's 13 times 9. Plug that into your calculator. 13 times 9 is 117. Okay, now we're adding those two rectangles together. So add those two areas together, 30 plus 117, and you get 147. And we're finding the area, so it was inches squared. This should look the same as example 1 on your foldable that we already did. Okay. Now, hopefully you're following along on page 16 in your packet. And I want you to actually, on your packet, since in the foldable we already did it the adding way, let's now try it subtracting. Okay. And what I mean by that is, for this particular shape, we could do adding or subtracting. It doesn't matter. It'll still give us the same answer. But sometimes it's only possible to find the area of a composite shape by subtraction. So I need to show you how to do that in case a problem arises where it's only possible to do it with subtraction. So how we do that is we pretend that what if it was this whole entire rectangle right here, and then we just subtract out this part right here that isn't actually part of the shape. So see how I just drew these dashed or dotted lines? This isn't actually part of the shape. Okay, so you have, pretend this is all shaded in orange, and then I'm going to subtract out that red rectangle right there. Okay, and then that will give me the remaining L shape. Okay, so that giant rectangle right here has a measurement of 13 by not 9, but 15. Okay, and you could have gotten that by from here to here is 9, and from here to here is 6, so 9 plus 6 is 15. Or this is the same as this. So if this is 15, so is this. But sometimes they don't necessarily give me that this is 15. They would have expected me to figure it out if they gave me that this was 6. I would have to know that 6 plus the remaining 9 gives me a total measurement of 15. Okay? And then you subtract out this rectangle right here, which is 6 by something. Okay, and I'll show you how to get that measurement in a minute. Okay, let's first of all go back to always when you draw your shapes, label them. It's 13 by, hopefully we've established, it's 15. Okay, and then you could look at this side that this is 15, so is this, or we could have said 9 plus 6 is 15. Regardless, you should have gotten this was 15. Now on to the harder part right here. Okay, we've established that this is 6, but how do I find this measurement from here to here? Okay, this part. Okay, well, if you realized that this whole thing is 13, how do I know this whole thing is 13? Well, because from here to here is 13. So if this is 13, so is this. Well, 5 plus what gives me 13? 5 plus 8. Okay, so then I know that this part is 8. So I'm going to go ahead and label my drawing that that's 8. Always, please make sure you write your formulas. I'm dealing with a rectangle, so I'm going to go base times height, which is 13 by 15. Plug that into your calculator. 13 times 15 is 195. Now I need to find the area of this smaller rectangle that isn't actually a part of the shape, because I found the area of this whole thing. Well, this part wasn't actually part of my original shape. See, it's only the dark line. So if I subtract out that rectangle, base times height, 8 times 6, which is 48. Okay, so go ahead and plug that into your calculator. 195 minus 48. And I'll get my area of just the remaining part right here, the L shape, which is 147 inches squared. And you'll notice the previous slide we just did also had an area of 147 inches squared, as it should, because it was the same exact figure. I just solved it one way by cutting the shape into two parts. I added this rectangle plus the small rectangle. Okay, I did it by adding, or you could have taken the whole shape, even part that isn't included, and subtracted out this little missing piece right here. Regardless, whichever way seemed easier, we still got the same answer. Okay. And if you're like, wow, I'm always going to do adding because that seemed, the first example was so much easier. I don't like the subtracting way. Okay, well, what if I had a figure like this? Sometimes subtracting is the easier way to go, because if I were to do this the adding way, I'd draw a line here, and that would be 5 by 7. Okay, that's not so bad. But this bottom part isn't actually a shape. So I'd have to not only draw it down here with this rectangle to my left, but also draw a line down here. So this remaining space in the middle is a trapezoid. Okay, the base is easy enough to find, that's 7. But this part is only from here to here. Well, if the whole thing is 7, 4 plus 3 is 7. Okay, so it has one base of 3, one base of 7. I also need to find the height right here. Well, this whole thing is 13 because this is 13. So the missing piece right here, 2 plus 5 is 7. 13 minus 7 is 6. Okay, so it has a height of 6. So base 1 is 7. Base 2 is 3. So add those two together, multiply it with the height, which we just established was 6, and then divide it by 2. And that was just the middle part. You still have this bottom rectangle, and that's 2 by 7. So you'd find the 2 by 7, this 5 by 7, and that middle trapezoid. If you're confused right now, good, you should be. That was really hard, right? So much easier if we were to instead have done this problem with subtraction. Okay? And yes, you could have done it with adding, but why? Look how much easier subtraction would be. Okay, I'm going to draw in this little dotted line here. Let's pretend that it was this whole rectangle. Okay, and then I just subtract out that little tiny triangle right here. Then that would give me this remaining piece. So that whole entire rectangle is 13 by 7. Okay, so you can go ahead and label that. But when I go to subtract the triangle, it's easy to find the base, that's 4. But how do I find that missing height right there? Okay. Well, I know that this whole side is the same as this side, which is 13. So if that whole side is 13, to find this missing piece, I subtract what was already given to me. 2 plus 5 is 7. So the remaining part, 7 plus what, gives me that whole side of 13, 6. Because if you add this whole side together, it should equal 13. 2 plus 6 is 8. 8 plus 5 is 13. Always double check yourself because sometimes some people just do 13 minus 5 and put 8 here. Well, don't forget there was a 2 here as well. So always double check. This plus this should equal the whole total side length, which should match this side length. Okay, so we've established that the height is 6 and the base is 4. Always, always, always write your formulas. Okay, beneath my rectangle, the formula for a rectangle is base times height. So 13 times 7. Type that into your calculator, you get 91. We're going to subtract the triangle. Always write your formula because this one is divided by 2. And some people forget to do that unless they wrote it out. So you have your base times your height, 4 times 6. Don't forget to divide it by 2. Well, 4 times 6 is 24. Put that over 2. 24 divided by 2 is 12. If you guys cross-canceled or reduced it in here, that's fine. You still should have gotten the triangle has an area of 12. Now, I'm not adding them, I'm subtracting it because this triangle isn't actually part of the shape. Okay, and I found the area of the whole rectangle, which included this part that isn't part of the actual shape. Okay, so I need to subtract this guy. So you go 91 minus 12, and you get an area of 79. And it's area, so it's feet squared. For both of these examples on page 16, we could have found them by adding or subtracting. It didn't matter. Okay. In my opinion, the subtraction way was easier, but hey, to each their own. If you still got number 2, if you divided it into 3 different shapes and you got an area of 79 feet squared, good job. Okay. Sometimes it works, sometimes it doesn't, depending upon what numbers they give you. However, if we come across a problem like number 3, the only way to solve this is by subtracting, because you can't take this large rectangle and add this rectangle and this rectangle. That will not give you the area of the shaded region. Okay, because once you find the area of the entire rectangle, you already did, right? You found this whole entire area. But I need to subtract out this small rectangle right here and this even smaller rectangle in there. Okay, so you find the area of the whole thing and you subtract this rectangle and you subtract this rectangle. Let's always draw our pictures out and make sure that they're labeled. Okay, so we have the big, large, light blue one. We're going to subtract this little red one and subtract the even smaller, darker blue one. Okay. Always label. This large one is 12 by 10. The red one is 4 by 5. And this little tiny blue one is 2 by 3. Okay. And of course, we always write our formulas. What's nice about these is they're all rectangles, so they're all going to be base times height. This first one, the base times height is 12 times 10, which is 120. The small one, again, base times height. And yes, I want you to get in the habit of writing the formulas out just so that you get them trapped in your memory forever, so you never forget them. And then also, so you don't do something silly and divide by 2 for some reason when you're not supposed to. Okay, so that's 4 times 5, which is 20. And then the last one, okay, that base times height is 3 times 2, which is 6. Don't forget to bring your signs down. Okay, we have the big, large rectangle, and I'm going to subtract 20, and then also subtract that other one of 6. Well, 120 minus 20 is 100, and then 100 minus 6 is 94. Don't forget your units. It was inches, and since it's area, it's inches squared. Okay. Please, please, please get in the habit of always redrawing the shapes that make up your composite shape and putting, if you're subtracting or adding between them, label them with your new numbers, because as we found in example 2, sometimes you have to find missing pieces and label them and the numbers change. It's just easier if you have them labeled on your drawings. And then always write your formula beneath each shape, plug in the numbers, and then work your way down. Okay, this is the best way that I can suggest so that you don't make simple errors, you don't forget to do something, or you don't accidentally do something twice. Okay, and congratulations, you just did that impossible looking page of page 16 in your packet. Congratulations, mathematicians, you now know how to find the area of polygons, or sometimes referred to in this particular instance as composite figures made up of multiple polygons. Good job, you guys.